Hello everyone, welcome to this video. In this video, we'll be looking at the subgroup lattice of the given group. So let us first see what is the subgroup lattice. Subgroup lattice is basically it is a diagram that indicates the relationship between groups and its subgroups. So it includes all the subgroups of the groups and it connects a subgroup H at one level to a subgroup K at some higher level with a sequence of line segments. If and only if H is a proper subgroup of K. So that means if we have K and if we have H and H is a subgroup of K and which is a proper subgroup, then we represent it like this with a straight line segment where H is lying below K, representing H is smaller and is contained in K and it is a subgroup of K. Right? So the relationship among various subgroups of a group, this can be illustrated with the help of subgroup lattice of the group. So this is a very convenient way to look at all the subgroups of a lattice by a subgroup lattice. Why? Because by having just one glance onto this lattice, we are able to identify all the subgroups and their relationships between each other. Right? As an example, let's consider the lattice diagram for Z30. So for Z30, we know this is a finite cyclic group and we have calculated all the subgroups of Z30. They are obtained by writing down all the divisors of 30, which are 1, 2, 3, 5, 6, 10, 15 and 30, right? In total 7. So we already know the subgroups generated by 1, 2, 3, 5, 6, 10, 15, 30. They are all would be obtained in this manner, having all these elements and having all these orders that we already know, and we have studied this in detail in the previous video, right? So using this, now we have, in order to draw a subgroup lattice out of it, we have to make certain observations. Now what all are the observations that you can make and so that you now have to write the lowest subgroup at the bottom, right? And the greatest subgroup, so the subgroup which contains all of them at the top most of this diagram, right? So you can make this observation that the subgroup which is generated by 1 contain all the elements or contain all the 30 elements. So basically this is your Z30 only. So this is your group itself and the group would contain all the subgroups. So that means the observation that you can make is the subgroup which is generated by 1, this contain all the other subgroups. Right. Next, you can see that the subgroup which is generated by 30, it only contains one element, which is the identity element. And this identity element, if you notice that it is present in each of the subgroup of this group Z30, right? So the subgroup which is generated by 30, that is contained in all other subgroups. So you see, you have the lowest element, which is this group which is generated by 30 and the topmost element as the one which is your group itself, right? So it is Z30 only, right? So next you have to see how can we arrange all the other elements within it. What are the relationship of all of them among them, which is contained in what, and so on. So for that, you can see the group generated by 15, it has two elements, 0 and 15. So can you identify 0 and 15 in any of the other subgroup here as well? So you see in the subgroup which is generated by 5, you have 0 and you have 15. So that means this subgroup 15 generated by 15 is contained in the subgroup generated by 5. And in fact, this is a subgroup of this subgroup, right? Next, this 0 and 15, they are also present in 0 and this set, because the next element would be 9, the next would be 12, the next would be 15, next would be 18, next would be 24 and the last would be 27. So you see you have 0 here and 15 here as well. So this subgroup generated by 15 is also contained in the subgroup generated by 3. So you have this thing here, right? So we have this observation that the subgroup 15, that is contained in the subgroup 5 and the subgroup 3. Next, let's see the other case. What about the subgroup generated by 10? It has 3 elements, 0, 10 and 20. So can you identify these 3 elements in any of the subgroups which are present above? So here we can see in 5 we have the element 0, the element 10 and the element 20 within it. So therefore we can write the subgroup generated by 10 is a subgroup of the group generated by 5, right? And one more thing, can you identify 0, 10 and 20 in some other subgroup? Yes, it is there. So we can see that in the subgroup generated by 2 we have 0, next element would be 6, would be 8, would be 10, it would be 12 and so on. All the even numbers would be present in this one. So obviously 0, 10 and 20 would also be present here. So that means the subgroup generated by 10 would be a subgroup of the group generated by the element 2, right? So we have another observation that the subgroup generated by 10 is contained both in the subgroup generated by 5 as well as the subgroup generated by 2. So we have our next observation here as the subgroup generated by 10 is contained in the subgroup generated by 5 and the subgroup generated by 10 is also contained in subgroup generated by 2. What all observation can you make next? What about the subgroup generated by 6? It contains the elements 0, 6, 12, 18, 24, which are multiple of 6, right? So can you see all these elements somewhere else also? Yes, all these elements, they are present in the subgroup generated by 3. We have 0, we have 6, we have 12, we have 18, next we have 24, right? So all the elements are there here. So we say the subgroup generated by 6 is contained in and is a subgroup of the subgroup generated by 3. Next, this subgroup is also contained, as it contains all the even numbers, so it is also contained in the group which is generated by 2. So therefore the group generated by 6 is a subgroup of the group generated by 2. So we have also this observation that the subgroups generated by 6 is a subgroup of 3 and that generated by 6 is a subgroup of that generated by 2. So we have this observation also. And you see 6 is not a subgroup of 10. Why? Because all the elements of 6 here are not present in 10. Similarly, other negations could also be calculated, that 10 is not a subgroup of 15, 10 is not a subgroup of 3 and so on, right? So that means you cannot compare the subgroups 10, 50 generated by 10, generated by 15 and generated by 6 with themselves. Then we have one more comparison, that you cannot compare the subgroups which are generated by 2, which are generated by 3 and which are generated by 5. So they would have the same level, and we would write down the containment of different subgroups using the line segments. So let's see, with all this information, how can we very easily draw this lattice diagram. So let's move forward and look at this. So you see, we had the subgroup generated by 30 at the bottom and that generated by 1 at the top, which is your group only, right? So next we have the subgroup generated by 10, that generated by 15 and that generated by 6. So you can see here all of them, they are not contained in each other, right? And and all of them, they contain the subgroup which is generated by 30 because it only has the identity element. So we can make this straight line segments over here. So this forms that, and this tell us that this contain the subgroup generated by 30, this also contain the subgroup generated by this, and this also contain the subgroup generated by this. Okay, so this is one part of the diagram. What about the next one? We also saw that the subgroup 2, the subgroup generated by 3 and the subgroup generated by 5, they are also not contained in each other. However, the subgroup generated by 2, this contain this 6 as well as 10. So 10, the subgroup generated by 10 is a subgroup of this one, and the subgroup generated by 6 is a subgroup of this one, right? Next, you can see that for 3, the subgroup generated by 6 is a member of this, and the subgroup generated by 15 is a member of this. So the subgroup generated by 15 is a member of this, and the subgroup generated by 6 is a member of this. What about the subgroup 5? So for the subgroup 5, you see the subgroup generated by 15 is a member of it, and the subgroup generated by 10 is a member of it. So you have this and this as here, right? Similarly, all of them, they are contained in the subgroup generated by 1, right? So all of them, they are contained in this. So eventually 1 contains all the subgroup through these lines. So if we say this is member of this one, so we can show it by here like this. We can move through it by any of the given paths, right? So it is up to us. So this is how you draw a diagram. So you can see we have a very nice and tidy diagram, lattice diagram for the group Z30 over here. So I hope you understood what is lattice subgroup and how they are used to draw different diagrams. Well, that is it for this video. Thank you for watching.